Welcome to David Alexander Maths Tuition. This is Chapter 9c, the sine rule, the ambiguous case. So what is this all about? So in a triangle DEF, DE is 8 centimetres, DF is 6 and the angle DEF is 44. Calculate the two possible values of the angle EFD. So I'm just going to draw just a really terrible triangle, just a little sketch here. So DEF, DEF, and DE is 8, DF is 6 and DEF is 44 degrees. Okay, and we want to work out this angle EFD or DFE, is this angle here. Okay, so I'm going to use the sine rule, so I can say that sine of 44 over the opposite side to that angle, which is 6, is the same as the sine of EFD over the opposite one to that angle, which is 8. So therefore 8 multiplied by the sine of 44 equals the sine of EFD, and I can work out that the sine of EFD equals 0.926, so therefore EFD is the inverse sine of that, and my calculator is giving me this answer of 67.85 to 2 decimal places. So this angle here is 67.85. Now what we need to remember is it's also possible for it to be something else as well. So if I just consider my sine curve here, so here it's 360, here is 180. So we know that the sine of EFD is 0.9, so here's our maximum of 1, so 0.9, let's just say it's here. So there's actually two possible answers, and I've only got this first one of 67. And what about this one here? Because it's still less than 180, so it's possible that this will work. So the next one is going to be 180 minus 67.5, and so I could also get 112.14 degrees as well. So there are two possible sizes of this angle. So if I draw a diagram to illustrate my answers, so I will just try not do too horrendous a triangle. So we know that, okay, let's just, okay, I think I've drawn this one a little bit too long. So if this is 8 and the other side is 6, so to make it look more like it should be shorter, I'll just draw it in here. So 8, 6, so let's just ignore that bit there and ignore that bit there. So this would be, so this is indisputably 44 degrees. Now at the moment I've got an acute angle which is 67.85, but I can create an isosceles triangle here by drawing another side here, which is side length of 6. So this is my isosceles triangle, so this is also 6, and this angle here is that is my 112. So I've got 112 there, and this was the one that I calculated originally, so 67. So be careful when you're calculating angles using trigonometry, because there's you get your primary solution from your calculator, but you should always consider that could be another value which is 180 minus that primary value.